Thank you all for joining, by the way. We are doing this session after a while. We did take a little bit of a break, but we have the added advantage this time where we have been given our own cloud access system. And all of you who are here, I mean, the ones who have opted to follow along with the code and work hands-on will have a chance to work hands-on with the same software that I'm working on, which is the PTC Cloud, the ThingWorx Cloud instance that is running courtesy of Etisalat. So all of you would have got login details. If there are any of you who've not got login details, who didn't get a chance to reply or something, please message either. So we sent you an email with all the details regarding regarding how to access. So everyone who had replied to us, we did send that out. But in case you didn't do that, you can still get access to our system. Just drop a line to either Diane or Amar. They are the co-hosts here. So both Diane and Amar will be the ones who will provide you with the login. So just contact either of them on the chat, and we can take it forward from there. In the meanwhile, let's get started. I'm just going to start off with my stream. 1 second. Okay. So welcome to the session. Like I said, as mentioned earlier, this is part of the FutureNow program that Etisalat also keeps very ready. Just a second, I'm just checking a little bit more. I think there are more people coming in. Okay, we've got a good turnout. We've got a nice big group. It'll be interesting to see how our server handles it, because this is the first time we're doing it with so many groups. We've done all the tests and all, but of course, the real life scenario is always different. Okay, so before we get started, let's just have a little bit of a look at the assembly. Most of you would have heard of it, obviously, through us, the assembly. So I'm guessing you already have a little bit of an idea. But just to give you a bit more in case you haven't. So we are a smart lab and makerspace that's based out of In5 in Dubai, Dubai Knowledge Park since 2014. And we keep doing free workshops for the community, including workshops like this, where we partner up with people like Etisalat and other tech giants. Our workshops cover a number of topics. We do hack workshops, which covers embedded systems, IoT, hardware. And when it's hardware and we do live workshops, we actually provide you with the hardware. So you don't need to bring your own Raspberry Pis or your own Arduinos. We provide those with you. And we, of course, provide all the added actuators and things that we need. Assembly code workshops, on the other hand, are purely code-based. Hack workshops will also involve a bit of code, but code workshops are purely code-based, and there's no separate hardware required. And we focus on APIs, frameworks. We've also, and today's workshop will come under both hack and data science. Assembly data science is something we started more recently to deal directly with AI and ML. And today we're using the platform, the ThingWorx platform, but normally we would use many different types and many different exercises. So do check back. We do all our workshops. Since the pandemic started, we've been doing all our workshops online, and you can see them at theassembly.ae, our website, even the past sessions. So there are lots of machine learning workshops there, as well as other ones. Our focus is on practical applications, and our audience ranges from students, professionals to entrepreneurs. Obviously, In5 is the entrepreneurship hub. So you'll see a lot of entrepreneurs also joining in, as well as professionals. From we are, of course, Dubai, and Dubai Internet City in particular is home to many internet company, tech companies, and there are lots of professionals who are interested in improving their skills. Social media, you can find us on Make Smart Things, and we have our own forum as well, so you can get all the details from there too. Okay, great. So that was about the assembly. Okay, I'm just going on seeing people coming in, so hopefully everyone is able to sort out with their. Okay, somebody's message on there that they have not been able to get the access. Please send a mail a message in chat to Amar or Diane, and they will sort you out with a username and password if you haven't already got it. So please do check with them. Okay. So that was about the assembly. Let's go straight into our topic. Okay, so I'm going to start with, of course, we are going to focus on analytics today. And this is going to be, any analytics workshop always starts with this particular description, and you will see this come up many times, when people do any workshops on analytics or any discussions. There are 4 types of analytics that are involved. And the basic ones are descriptive and diagnostic. What happened and why did it happen? We're not going to focus so much on these two, although descriptive will come up, and I will describe, will show you a few things related to that in the course of our exercise. we're going to focus on predictive analytics, which are more advanced analytics where we can want to predict what will happen. And these all of these inform decisions, and we can take actions, decision support, and of course, prescriptive analytics takes it even a step. We're not going to look at that right now, but prescriptive is something to fix and to automatically fix based on your predictions. But we're going to focus in on predictive analytics. So let's have a little bit of more of a look at that. So what are predictive analytics? Predictive analytics applies machine learning to historical data to make predictions about future outcomes. So of course, IoT is based on a lot of data, and historical data is really important, of course. We store the values. It's not just the current values. So if you have a sensor, you store the current value, you store the history, you store a lot of ancillary values also, and putting those all together makes it ideal for machine learning to predict some outcomes. So we could have things, the example use cases could be predicting failures, so a device could fail, or the quality of service, is it doing as much as it should? We could determine when a device that's connected to the Internet of Things requires service. And of course, from a more sales perspective, we could say that we could predict sales and risk churn. So you can see the center part where we've got the predictive model. That is the interface that we will be using. And of course, like there'll be all sorts of intelligence that comes from there, the probability of error, the different things. And the thing model is actually defined in, we will show you that, of course. Just a little bit more about ThingWorx Analytics. ThingWorx Analytics Server is a separate installation from ThingWorx. You don't need to worry about all this. We will be providing you a ready-made thing. But if you were a cloud admin who wanted to install, you would have installed ThingWorx out of the box. You would also have to install ThingWorx Analytics Server separately. Now, it's a separate installation which contains microservices and components that expand the basic ThingWorx foundation, so which add on these capabilities. The main focus is the Analytics API, which shows how you can interact with these analytics services, and everything is based out of that. Everything is service-based, so you could write programs that deal with the Analytics API. For those of us who are using ThingWorx, luckily we have something called the Analytics extension that adds a tab to the Composer, which we've used before, and includes two separate features, something called Builder, which generates the models and it does all the machine learning work. And we'll see all this now. PMML format is predictive markup. So like HTML is there. So it does have a standard format, and you can export in that format to get your models. And Manager, which helps us operationalize. So when I say operationalize, and I'll show you that in the next slide, operationalize means that we want to take models and we want to put them into working on live data. So if you have a sensor that is connected, a smart device that's connected to the Internet of Things, and it is bringing data into the cloud, we want to be able to run predictions on that data in real time. And we'll show you how to do that also using the model. So the model will provide the core for that. So that's Builder and Manager. The Analytics extension, this is important to remember also, is just a collection of mashups. We've built mashups in the past. Mashups are ThingWorx web applications that you build completely from within the within the interface itself, within Composer itself. The Analytics extension is a collection of just web mashups that have been created, and it just wraps around the Analytics API. So you've just got an interface that calls the API. So when you see it, it's nothing special. It's just something that even you could develop on ThingWorx and deploy in your own form. So this slide is completely superfluous mostly. This is only something an admin would really have to see. This is just the architecture. On the right-hand side, you can see the API, the things that add on. So ThingWorx has a lot of built-in things, as we've seen in the past. There are thing templates. There are things. Thing templates are like base classes. Things and other shapes that allow us to expand, to provide a data model, not a machine learning model, a data model, so that incoming data that comes from the edge to the cloud can be stored in a structured format and can be processed using services, etc. And on the left, you can see the structure of the ThingWorx Analytics Server, like how it there. And this is all under the hood. Zookeeper, the worker threads, these are all running on the server. Fortunately for us, this time we will be using the Etisalat VM, and all of this has already been configured on the Etisalat VM. So don't worry about all this. There's a separate database from Analytics Server. Okay, now this is an important slide. This is something that you will see in practice also. ThingWorx Analytics Builder is the component that allows us to take data from ThingWorx that we upload. We build a predictive analytics model with it, and then we publish the model from there where it is available to Analytics Manager. Analytics Manager, on the other hand, is for operationalizing the model. So Analytics Manager takes the data and that is coming in live from the edge to the cloud, or just simulated on the cloud as we'll do, and applies the prediction from the machine learning model on it, through the provider that has already been given, and then outputs results. This ThingWorx Analytics Manager just completely wraps up, or completely like integrates with ThingWorx things. So the things like, for example, like, and we'll work on that. So when you operationalize the model, you are using ThingWorx things to, call that. So don't worry if it sounds a little bit confusing. I know many of you are seeing this for the first time and you haven't attended previous sessions, but we'll give you an idea about that. Okay. Now, this is another, just a basic slide. I'm rushing through the slides because we want to focus more on the hands-on part, because we've got a lot that we have to see. What you just have to, this is just a little bit of an idea about how Builder works in ThingWorx and how prediction models in general work. And a lot of this is similar to how you would be used to prediction models in other platforms as well. ThingWorx takes your training data, it takes your data set that you align it to and divides it into two. By default, 80% of your data is reserved for training, which is to build your model, and 20% is held out separately to test out your model, to see how good the results are. This is a standard practice, and you would have all seen this. Of course, you can always change the ratio, but 80-20 is kind of the usual stance there. The model building, ThingWorx is very advanced, and out of the box, if you just use the default, you can just build a model which is fairly good because it gives you different options. You'll see a few different things here. You all know linear regression is the simplest model, which is just like, where you're trying to fit points, like, where you're trying to draw a line through points, and it's the simplest, but it's not necessarily the most accurate. So, because obviously nothing is linear when it comes to data. Decision trees get a little bit more complex. Decision trees partition the data well especially for classification, and logistic regression is also used for classification. So those are two tools, and you have to decide how you use these based on that. These are all terms that are common to, that are familiar to people who have a knowledge of machine learning, and these are all different types of things. Logistic regression, like I said, is also for classification. We wouldn't normally, if you're doing things that need linear regression and we want to improve that, we wouldn't normally switch over to logistic regression. Decision trees might help with that, as would, so SVMs are another type, support vector machines, which can be used with predicting Boolean outcomes. So if you want to have like a failure is true or false, you could use a support vector machine. Neural networks are the most important, obviously. Neural networks are the ones which have like anyone who's like, been paying attention to machine learning of late would know what a neural network is. It's basically a model that is based on the human brain itself, the way our brains work. So you have neurons, and it takes the input layers, which is your data, passes it through a number of intermediate layers where, it's twisted and changed and all that, and then finally gives an output layer. So it maps from your input to your output by going through many layers in between. So they can be hidden layers, and ThingWorx actually allows you to set a lot of parameters. You can set the layer count. You can set how, what your activation functions are. Activation functions can be used to stretch out the data at the end to normalize it. For example, if you want to, you would have heard of terms like ReLU or sigmoid. So if you want your output to be a sigmoid shape, that would be done using the activation function. The most complex are also supported here, which are the two, random forest and gradient boost. Now, random forest and gradient boost both use multiple decision trees. And, random forest takes it randomly, multiple gradient boost actually takes them sequentially. And ThingWorx allows you to work with them. You can specify the number of trees, you can specify the maximum depth, like the maximum number of trees to create. And these trees branch out and they work quite well. And they're the more advanced models, but they're quite accurate. Now, I said the default ThingWorx option works quite well with this. The way ThingWorx applies it is, it doesn't just let you apply one model, you can apply an ensemble of models. So you could say, I want to apply linear regression, I want to apply neural networks, I want to apply gradient boost and decision trees all at the same time. And you could take the ensemble and you could, it will automatically score. So it'll run each of them separately, and then it'll take a common score. You can decide how the score is taken. Is it taken from the average values? And I'll show you this more when we actually get into that. So it would take the scores according to that. It would take the, a lot of the different things, and so you would get the best result possible. So if linear regression is applied and it's not, and the result is not great, it'll just be thrown out. ThingWorx will take care of that on itself. So keep an eye for that. We will see that later on. We can validate and optimize. Once we're done with that, the model's ready for production. Production means we can put into operationalize. Don't worry if you are not understanding everything. It'll make a lot more sense once we actually get into working hands-on. Okay, let's go to our next one. So I promise this is the last few slides. I set a deadline of 15 minutes for myself, and I think I've always made it. The data sets that we're going to be using, we have 3 exercises. Well, we have 2 exercises, and one, if we get time, we'll look at it. But we will try to do a little bit of homework. And like I said, you can use the server. I'm going to keep it up for the next few days also, at least. So in the next few days, you can definitely practice with the data the way we are going to do now. The first data set we use, like I said, this workshop is going to focus on real world data. So we're taking data that is not like last time when we did workshops, we'd use simulated data that we had from PTC. We're going to start with something that predicts the compressive strength of concrete. Now, this is an old data set. It's from 2007 from Taiwan. And it was put up to, like, you can see the link as well. In fact, let me see if I can share my screen and, let me just share my whole screen actually. So I can just, okay. I wanted to show you actually, I'm just going to open up a browser window. Actually, forgive me, I'll just come back to this. Let me just stop sharing and come back to this in just 1 second. I'm just cleaning up a little bit of my bandwidth. I just want to make sure I can log in. Okay. Sorry about that. Let me just go back to sharing, and I will come back to the device. Okay. That should do it. I'm just making sure I keep my VM ready so that as soon as as soon as you guys are also on there, yeah, I think that should be it. Okay. Let me just reshare my screen. Yeah, I hope everyone can see everything. So let me share my screen now. Okay, I'm going to share my whole screen. So just hopefully you can take a look at that. So where did my PowerPoint go? Resume slideshow. Okay, so the first data set, like I said, is about the compressive strength, and there's a link there. So it's actually been provided for an ML data set. So I'm just going to open up my browser so you can have a look there. In fact, I'd already saved it. Yeah, that's the link. So this is where I got the data set from. It's not a very big data set. You can see over there. This is a very industrial purpose machine learning thing. You want to predict how strong your concrete is, and you have the data set which has, of course, the result, the compressive strength, which is a score that's given to it. That is our thing. And this is a typical regression problem. We want to predict the compressive strength based on other features. So the features are cement. I have no idea what all of these look like, but I can understand a few: cement, water, the age of the material, the coarse aggregate. So 4 different values of these particular features, we want to predict the compressive strength. So we'll be starting off with that, and we'll be going through everything for that particular. Anita, where did my presentation go? Okay. Our second data set is also interesting. That is something that has come directly from PTC for a company called BeanPro Espresso. So these are espresso machines, and they have a very advanced setup where they have networked espresso machines. If you know, like some of the history of like network devices, like the first webcams, for example, were invented for coffee machines, but now coffee machines and IoT make a good combination. So BeanPro has networked espresso machines all around the country in the US. And we are getting data for its failure. When does a machine fail? When do the individual components, so the pump, the grinder, the different parts of the machine, they fail? And how does it relate? Again, this is another prediction tool. Only the difference is Here, the result that we're looking for is Boolean. So it's either true or false. And finally, the last data set, I'll come back to that if we have time. That is a data set for water potability, and that will be our homework data set. We've already shared all the data with you. You don't need to upload anything because everything will already be on the system. But for your reference, we've shared a link which you would have received in the email. You can take that link. It's just like, you know, the same as our server link / analytics workshop data. That'll contain all the data sets that we have in CSV format, and we're not going to use that. You will not have to do anything with it, but you will see on that. Okay, and this is my last slide because we're going to move over to the online cloud access. Okay, now online cloud access, we are going to work from ThingWorx-srv.theassembly.ae. All of you have been provided this account. So this is the first time we're using it. So you are going to be able to work hands-on, and it's not only going to be for this session, we're going to be using this link for all sessions coming forward, you know. So we will be like, you know, whenever we work with things, you will not have to install anything. You will not have to use the trial version like we did before. You can just log in here. And like I said, in between the sessions also, I will keep it active, though I will from time to time, you know, refresh the thing in case it gets too cluttered. A couple of rules for that. The first one, please prefix or suffix all the things and models you create. We are all going to be creating things on the same. So right now, there isn't a way to like sort of, you know, your models. If you create something, say model, you know, it'll just like, it won't allow you to do that because somebody else has already created that. Make sure you create something called model underscore, in my case, Nikhil. So I'll say model underscore Nikhil. And please also make sure that you don't edit someone else's model. You know, it will give you a warning, but still, just to be safe, please, you know, respect other people's objects and whatever they worked with. And the last thing is, while logins will persist, don't count on the data persisting. The data, I will be cleaning up the data from time to time. For the models, I will still leave it a little bit. The analytics part, I will leave it for about a week at least, you know. So if you're working on it and you want to carry on, do that. If you want to persist the data, you can export. You will all have export permissions, so you can export either as a TWX or as a, either as a binary TWX or as XML. It's very easy to do. You'll see an option right there from Composer. So if you want to save your data, and if you have any issues with that, do send us a message, and we'll let you know how to do that. So you will be able to persist data, but don't count on data being persisted between sessions. We'll be doing the workshops once a month, so you want to make sure you back up your data if you want to keep it. Okay, I think that's about it for the slide part of it. Let me just stop sharing, and I will start sharing my, make sure that my, okay, so I'm going to start sharing again. Yes, we are getting the thing. We are using a self-signed certificate. We are moving towards a domain name. So it would be, it's still in process. That's the problem. We are using, so that is secure. So don't worry about the security warning. We are just going to be going to HTTPS, and we are going to have a domain name. So we're just waiting for that to come through, and we didn't want to postpone the session for that. So don't worry about the message. The credentials, if you want the credentials, you can just speak to Amar or Diane. We have sent out credentials to everyone who replied and asked for them on online. So please do get the credentials from Amar or Diane. They have plenty of spares, and we can see how to work with that. Okay, I'm just going to go back to my data and share my screen. Okay, I hope everyone can see my screen. So I am on the server, the ThingWorx VM that we have, and you should all be there. You can see, actually, I've created a lot of different users. Each of you has a custom password. Now, if you've attended previous sessions, you would be familiar with all these tabs except the last one. The last one has been added as an analytics tab. Analytics, like I said, does not come out of the box with ThingWorx. So, so you do have to, separately do that. Now, just to give you the 1 minute recap, ThingWorx, like this, the rest of ThingWorx, excluding the analytics part, models data that is coming in from the edge on the cloud. So it maintains twins of data. So if your cloud device is a Raspberry Pi, which has a heat sensor, you might have a thing called Raspberry Pi on the cloud, and it would have a property called sensor. So if I this is an example of a thing, so a thing has properties and alerts. So this particular one, for example, has got like, this was something that we had actually used for the previous analytics session. So it's got properties like low grease, which is a Boolean field, and it's got other fields, where it predicts values. It's got an info table. So things like this are there. Things can also contain services, which are just functions that invoke. There are lots of inbuilt things also. So the things are the bedrock of everything to do with that. But if you've attended our previous sessions, you've definitely seen ThingWorx things, and we've used that. We've used mashups also. Mashups are how you build your cloud web application. So they're very powerful, and we will use that a little bit. But for today, we're going to focus on analytics. So I want everyone to, before I do that, everyone should remember that import and export comes from this. So if you do want to export your data, any data can be exported to a file. Like you can, you should just select a single entity, and you can, like, everything in, by the way, is autocomplete. So if you wanted to, for example, the entity I just showed you, AMQS thing, if you wanted to export that, you could export it to either binary or XML, and you'd get an XML format. And then once you say export, you could get that item. So if you are creating data, if you are creating things and doing different things, you should definitely export that. Okay, so let's go straight into analytics. Like I said, there are two parts, Analytics Builder and Analytics Manager. Let's focus only on Analytics Builder to start with. And I'm just going to do a quick 1-minute recap of what we did the last time around, the session. So these are the data sets. So with the previous workshop we did on analytics was a simulated data set called engine vibration data. Now this engine vibration data had 10 prediction fields. There were 10 sensor data fields. They were numbered. They were S1_P1. So they were supposed to represent the fan belts of the engine, and there were like 10 engine fan belts. So these 10 values were supposed to predict whether there is engine failure. And this is the data set we used. Now, we were talking about descriptive analytics before. There are two types of descriptive analytics, which will be useful to us in predictive analytics here also, which are signals and profiles. Okay. Now, signals is an analysis of the data set. And when we ran this on engine vibration signal, for example, we did a scan, like ThingWorx runs a scoring. So it tells us the prediction, the goal value is failure. So that's a field which is just true or false. And to predict that, it did an analysis. It said, first of all, like S1FP1 is the one feature. S1FP2 is another feature. It does a scoring for how influential those are in predicting failure. So, and it gives us, of course, all sorts of statistics. So it said when the value was 216 to 235 for S1_FP1, that was our average goal. So again, if you can see our previous session, it's on our website. We did this in detail, and we showed you everything with that. So S1FP1, what this tells us basically is that S1FP1 was the most influential in predicting failure. So that field alone would tell us the most, and whereas S2FP5, which is another one, could be excluded. In fact, if you see, all the ones that were prefixed with S2 were lower in information. So we actually made the decision that we could just remove 5 features, which isn't a big deal when we're computing a machine learning, but when we're getting an operationalized model, you save a lot of data by getting rid of 5 entire fields. So 5 entire values were completely removed because of this analysis. So that's how descriptive analytics, like we did, feed into predictive analytics. Now, the same way, signals are for single fields. It tells us about single features. Profiles tells us about combinations of features, okay? And engine, like it tells us, and you can do all sorts of parameters, will show that. But it told us, for example, the first profile that it gave, which said S1FP2 and S2FP2, FP1 and S1FP3 and S2FP2 gave us the most, the best predictions. So it said like S1FP2 alone gave us like, it failed in about it gave a failure status in 19.77 records. When you combined it with S2FP1, you did that and it came to 13.44. These are all good numbers. It also gave us pretty, and you can also see the average goal values. So the goal was it was Boolean, so it was 0 or 1, but so it was scored from 0.58. So you can see how many records, I think. This gave about 12.65% of the records, which is a high number. But there were other profiles that it gave, like, which were much lower, which gave like say 2.73%. So this just gives us some description of our data set and what is the best format to do that in. Okay, so I just wanted to show you a little bit about what we did last time so that you get an idea. So there's a little bit of a continuity. just in case you're not understanding, just to give you a little bit more of an example, signals and profiles are, how they explain. Say you were right creating a model to predict the weather, for example. Okay. Now, when you're talking about predicting tomorrow's weather, one data field that would be useful would be the month of the year, more so than say perhaps the particular day. So if it's January or February, I can predict tomorrow's weather better based on that than say the particular day that it is, right? Because the weather could change day to day, but there is a particular trend when it comes to month of a year. So the signals would show me in that case that the month of your year is more influential in predicting weather. And my profiles would be more likely to include the month of the year rather than say the particular day or the value there. However, if you were doing, like say if you were predicting traffic, it would be the other way around. The day would be more influential than say the average over the month. So it's important to get this understanding of how influential fields are and how things work with that. And you can always cluster them as well. The most important part here, this is proper prediction. This is where all the work happens, is the models section. And we built a model around this engine vibration model, and we trained it here on with the goal as failure. And this gave us this is our model that's being built. This is an existing model, and it gives us ThingWorx automatically gives us some metrics that's built into that. You can generate signals and profiles from here if it hasn't already been done. We decided to discuss this. This is called, of course, an ROC curve, which gives a good indication of how well the training has gone through. So ThingWorx actually separates out validation metrics. Remember, we said 20% of the data, and this would be the training metrics are there. And you can see the ROCs are here, because we use simulated data, they're pretty good. And for both training and validation, they're quite similar. See, ROCs are good. The area under the curve is a crucial value here. So the ROC, what you see here is 0.937. It's basically saying 93% of the curve comes under this. So that is a good ROC. So that's a highly accurate. And when your validation ROC and your training ROC are similar, that's a good sign also. Sometimes you might have the training ROC looks good like this, but the validation ROC doesn't. So that could possibly be when you overfit data. So from a model, you try and it fits too closely to the actual values rather than generalizing enough so that you could see something based on that. What the ROC does is basically, this is just it's just it plots the false positive rate versus the true positive. So what is the false positive and true positive? Again, we explained in the last session. It divides your records into four categories. One are the true, which were actually true. So where your model predicted it would be true and it actually turned out to be true, those go in the top left-hand column, the accurate true. The accurate false are the ones where you predicted it would be false and it actually turned out to be false when you're validating the data. False positives are when the data is actually false, but your model predicted true. And false negative is when it's actually true, but the model predicted false. So you want to keep false positive rate and false negative rate down as much as possible. And this is pretty good. 26.96% and 1654 records are under the accurate. This is now validation. And the same, they're 60.8% in the other one. And false negatives are still there, but they're fairly good. And this is on the validation side. If you look at the training metrics, it's about similar, 60 and 30, and again, it's similar. That's why our ROC is similar. So you can also look up precision recall. These are scorings done on that. Precision is actually, the true positives divided by the total of number of true observations. Specificity is another. So these should all be high, and these are all good values. And when we work with real world data, it might not come this well, and you'll see that when we do the comparison. Also remember that this only works for Boolean data. It works for other data, but you will only get the ROC or the confusion matrix for Boolean goals. So Boolean goals, like in this case, we have failure, which is true or false, you will get an ROC. For the other ones, you'd get other measurements like RMSE and Pearson coefficient and things like that. In fact, our compressive strength, the first data set we're going to use is actually, it's a continuous data. We're not getting a true or false. We're getting a range of values, going from 38, whatever number to anything. So we will not get an ROC for that, but it's useful to know ROC. When we come back to the Bean espresso data, we'll see that also. Okay, so we've got all that. I'm not going to linger on this too much because this was last time's workshop. Just something that you should remember is that you have to look at these. So let's get started straight away with our data set. Okay, I'm going to show you, and don't be worried if I show you something that is, this is something I use called Total Commander. It's basically File Explorer with 2 panes. It's just something I used very long ago, so I've actually stuck on with that. So don't be shocked to that. I'm just going to go to the data. This is just, you can do this in Windows Explorer. There's no difference. This is actually what I've shared with you already, in that zip file. So all these data sets are already there. You don't have to do anything with it. I'm going to upload the data, and then you can use the same data that I upload to create your signals, and you can create your own models. So what I'd start off with is, let's go to the concrete data. Let's look at that. There are 2 files related. We don't need the JSON. The JSON is actually a metadata file. If you look at it, this tells us the types of fields, and it's better to define this so that it knows the type of data. Oh, okay, you can only see the browser. Let me stop share and reshare that. Thanks for letting me know. Okay. I'm going to share my whole screen. Can you see now? Yeah, good. Okay, so this is the metadata field, which is like, it's a better practice to define the data and what type it is, especially like, you want to say what's the op type. So we say continuous, it could be continuous, it could be Boolean, and here our goal type is continuous, but in the previous one, it would have been Boolean here. Time sampling, these are all, default things. You can leave it as it is. This is in JSON format. It's not necessary. Again, you can put the data and it can find out metadata from the thing, but it's better to have a metadata defined. Okay, and I'm going to open up. This is my CSV file, which I had got from that site. We haven't cleaned up the data much because it was already pretty much on there. This is our goal field, compressive strength. And you can see it's a range of values, so it's continuous. And these are our features: cement, slag, fly ash. There are a lot of zeros, so maybe those will not get, but we let the model take care of those. So coarse aggregate, fine aggregate, the age. So all of these are different features, and compressive strength is our output. Okay, so I'm going to close the data, this one. This is just to give an idea. You can look through, you all have the CSV file already. So let's come back to that. So the first thing we need to do is we need to upload our data. Okay, so I'm going to upload something and I'm going to call it concrete_data. I need to choose my data set file, and I will just, where did I get that? Let me just, I'm going to select it here. I just copied and pasted the whole path. I hit enter. I can decide to upload metadata. Since I have metadata, I am going to already upload it. This, by the way, like the metadata and all was created by T-Sci-Fi over at PTC. You can see him on the forum as well, just to acknowledge. You can review the uploaded metadata in this case, since we already have the metadata, and then you just hit submit. Now, since I'm uploading this on the server, all of you can use this data. This is just telling me, I could change my op types or my data type if I want it to be a string instead of double. If I want it instead of continuous, if I've wrongly marked it as Boolean or categorical or ordinal, which is sequential, I can do that. So I'm just going to do it as it is, and I'm just going to say create data set. Once I create this data set, you all can use concrete data to run your models also. Okay, so please stick with that. Okay, so we have our data set. It's 1030 records. I'm not going to, there is also, we are not going to cover time series in this workshop. We might do it in a later workshop because time series requires a different category. Time series is really important for IoT because a lot of the data you get is in a time series, and there are ways to handle it. But in this workshop, we're not going to go on time series. We're only going to concentrate into like kind of snapshot data. So just focus on that. So we've got concrete data. Our data has been gone in there. We're going to generate signals. We could do that later on also, but the process of generating signals, all of you don't need to follow along with this. I'm just going to do it just for, it's very simple. You just say concrete signal, you select the data set, which is concrete data. It automatically picks a goal, but we want to select, our goal is actually compressive strength. We don't have a filter. We can restrict the number of records if we want, but we don't need to. And then we just hit submit. We can exclude fields also. This takes It's fairly quick. We can create some profiles also. Since this is being done asynchronously, I can leave that and come back to it because it is being worked like on in the background. So my server is there. So I can create profiles at the same time. So concrete underscore profile. And again, I'll select concrete data. Not sure why it picks cement, but most of the time it picks quite well on its own. And we'll just create the profile. So while that's running, I'll go back to my signals. And you can see that it's already done. So it gives us some interesting descriptive analytics here. So we can see that the cement value is the most influential when it comes to predicting compressive strength. And you can see like the different values, like how many of how many of the records are printed. So it does a nice analysis of that. And we can see from here, the three most influential are cement, water, and age. So although we'll start off creating our model based on all these features, later on we'll refine it maybe so that we only use a few rather than wasting the time needed for the other or the extra bandwidth. We can see that things like fine aggregate fly ash have very little influence. So 0.04 is pretty low. So we could definitely do that. Now, this tells us about the fields. Let's look at the combinations. So the profile, again, it tells us, again, based on like we saw that age, water, and cement were the three features that were most influential. But it tells us that 6.31% of records, the goal was predicting quite well. So these three fields, if we chose, we could use only these three fields and we get a fairly good. But 6.31% is a little bit lower than our optimum. So we might not just restrict to these, the other ones might be more useful. So we're going to go straight into, Okay. The first thing we're going to do is we're going to build a linear regression model for this. Since it is a regression problem, let's start straight off with that. So again, we just go to new, and all of you can create these models and do this, and you can practice with this. It'll be interesting to see how it works when all of us are working on the same time, but it's quite robust. So I'm going to call it concrete underscore model, I'm going to say LR underscore nickel so that, in case you create something, it's not confused with that. Again, same way, the data set has to be selected. The goal is compressive strength. Models will obviously take a long. Now, if you see here, like this is where last time we rushed over this a bit, but we're going to look at it. We're going to play around with this a bit more this time. Validation holdout is how much of the data is going to be in your training. So 20%, like I said, is default, but we can change that. Redundancy filter is an interesting one. It's an inbuilt feature. If we select that, it will automatically eliminate fields that seem to be repeating. So if features are kind of like providing similar roles, it'll automatically take that out. So we validate on training data. So it is good. That's how you select. The maximum number of fields used to make predictions. In this case, 25 is way more than the fields we have. We just have 7. So, it's not going to matter. Confidence models you can create also on this. And maybe we might do that in a later version. Sampling strategy is something that's only there for Boolean goals. So how it samples when you're doing that. It was there in the previous, but it's not. Confusion matrix also will not be there. So it's not available here. And time series parameters, of course, we don't need to. Now, what's important to remember is we were talking about learners before. So learners are all the different methods. By default, ThingWorx will populate these. And these are usually good enough. Like it will run decision tree, gradient boost, linear regression, and a neural network. And it'll pick the best. So the ensemble technique it uses is called elite average. So it picks the best, output, and then it averages them. So if out of these, for example, if decision tree and gradient boost provide the best results, it'll only take those two. It'll ignore linear regression and neural net, and it'll just average out the values that you get. And the resultant is an ensemble value. So it's a very advanced technique, and this is something that is a great paradigm that's used right now. You can also use different methods. So it could just do an average of all, whether they are elite or not. It could take the best value, the best single one. There are other options. There's something called a soloist. If you only have one layer, it comes on there. The comparison metric it uses to compare the different methods, it's either Pearson's or RMSE. RMSE, of course, is the root mean square error. So it's the, it's the error that, if for those of you familiar with statistics also, you can see, in terms of standard deviations, how much the predicted value differs from the real value. So when you compare your validation to your training data. Now, this is a pretty complex thing. I'm going to actually remove all the learners from here. I'm going to select them one by one and remove all them because I want to only do linear regression. So here, Each of these has different parameters. Linear regression has no parameters. If I go to decision tree, you'll see there's things like maximum depth. If I go to gradient boost, there are much more. How many iterations go? Neural network, of course, it says hidden unit percent basically says how many hidden layers are there. So it gives like, if you have 10 input layers, so 10 input values, it reduces it to like say 2 hidden layers. So it kind of telescopes the data. So all of these can be this thing. You can select the hidden layer activation function. So you could do sigmoid, tanh, relu. Relu, of course, just like, just takes anything that's negative and makes it 0. The output layer is, of course, what we see. If we do the output layer as sigmoid, the output data, the output values will be all in like that S shape, like a sigmoid shape. So it will be scaled according to that. So these are all things that if you are familiar with machine learning, you would have done that. But in our case, we only want to do a simple regression. So I'm just going to use that. And I will just say add. Now it's there. And the ensemble technique is soloist because I've only got one. Now, when I hit submit, okay, this might take a little while. And I can see Utkarsh has already started. So all our data is there. So Utkarsh has actually got a pretty good RMSE. So remember the average value, if you look at these, the RMSE, and I'm just going to use Utkarsh as an example because you can see the model details here. These are the fields that Utkarsh used. So he used all the fields. He didn't change any of those. It gives you all the range and values. And the model configuration, I think Utkarsh used the default one, which is decision tree, gradient boost, linear regression, and neural net. And then the ensemble technique was applied and it picked the best. So we don't get an ROC here, okay? Here we get the RMSE and we get a bubble chart. And we'll come back to this later after I do my linear regression. So the RMSE is the key value here, which says 5.5. The average value is 35. So when you're talking about on average, your goal values are 35 and a 5 RMSE means that there's a little bit of variation, but it's still pretty good. So let's go back to our model that we did with, Now let's go back to our model. By now mine would have been created. Yeah, I see a lot of people are creating models at the same time. You might get queued as a result of that, but my model is completed. Now this, remember, is the simplest. It's a linear regression. And if you look at the graph, this bubble chart actually shows you where the line forms. If you look at all the green values are predicted results. So it says 65% is accurate. That's not great. And 65% you can see here is going straight through. It's actually linear. So you can see that's why a lot of the values, the outside the range. So say, 14% were over predicted in the sense that they were like 25. These are the yellow bubbles. These were well above the rate. So this gives you a scatter of all the data and it says where the predictions actually fell in there. And you can again see the training metrics also. This gives you another one. So this is the input data. This is the input data that we use, all the records. So you can see where the line is going through where it predicts there. These are the values that were outside the range. And you can see even in training, it was pretty, it wasn't great. It was 63%. So it drew a line through the middle. And then it just kind of like, the model just basically predicted and it just all came in here. So this is not great. And you can see the RMSE that we have here is 685. Whereas where Utkarsh did that, you saw that Utkarsh actually did it using the ensemble techniques. And, the actual results, sorry, one second. Yeah, so the actual results, the 10.68 means that the value could be, like at least 10 away from that. The Pearson is also another interesting way to calculate that. It's between 0 and 1. It's between -1 and 1. -1 means perfectly negatively correlated between the fields, between the prediction and the input, whereas 1 is like perfectly positively correlated and 0 is no correlation. So the Pearson is a good value also to consider this. And you can see some other values. R squared adjusted is normalized. R squared is just taking the root mean square values and just putting them together. So we know all these things, these metrics tell us. But this bubble chart is the most interesting one. So where it says that 65.42% of our records were predicted accurately, which is expected, because you can see it also, it's linear. So it's just kind of only the ones that are near the line are coming in correct. So our model is not great for working with this. So linear regression is not a great tool for this particular data set, in my opinion. And you can see the breakdown also, the green is here. Now I'm going to come back. I was going to actually create another data set, but since The others have already created the models. I'm just going to use one that they've already done, and I think everyone's model run. Let's look at Utkarsh's data set, because he got the, if you look at it, he got the best RMSE scores. So others, RMSE, by the way, the training and different people might get slightly different values. It's not always the same, because the way it picks the training data could change a little bit. So you might get slight value changes, and you might get things. Of course, if you tweak your parameters, you'll definitely get different versions. But Utkarsh has got the best value here, 5.5, because he used the thing that's out of the box, the neural network. So we already know that. Let's go and take a look at Utkarsh's data here. Now, if you look here, his predicted results are 88.36, which is great, compared to what we had, 65.2. And if you look at the training metrics, this is not a line. So you can see where the differences are there. Like it's actually average over there, and that's why there's a little bit more spread. Like, so your green ones, your accuracy in the training is actually as high as 95.4. Most of your data has come in there. So it's nicely mapped it out. And even for validating, it's worked quite well. You've got, it's not 95, but it's 88. And there are very few. There are 0 records which are under predicted. There are 2.12 which are, and 8.99 which are between 25% to 75% away. And there are only 0.53% which are in the red zone. That is like, so we've almost completely eliminated the wild predictions. So a lot of this is contained. So this is a fairly good one. And you can see your Pearson has gone up to 0.95, which is a fairly good value. 1, remember, is the maximum. And you can see R squared is also there. And your RMSE is down to 5.5983, which is half of what we had. So just by using the ensemble techniques, we were able to get this down into that. Okay. Now, this is great. And we are going to, that means that, in this case, we should use, I'd recommend you probably play around a little bit with the different data sets, and you'd find a little more with that. Now, I'm going to take this model and I'm going to operationalize it. Okay. Now, what that means, operationalizing the model, is is where I want to apply this so that I can take this model and I can use it on live IoT data that's coming into my things, into the cloud, and I can predict in real time. So how do I do that? But first, before I do that, I'm going to create another model just to be safe. I'm going to actually, right now I've got too many features, and I know that there are at least 3 features which are completely, pointless. So I'm going to create another model, which I'm going to use for my operationalized. Again, so say concrete underscore filtered underscore, I'll just say NS. Compressive strength. And this time I'm going to exclude the fields that weren't there that great. If I remember correctly, slag, fly ash, and fine aggregate were not that influential. So I'm just going to select these, and I'm going to say exclude these fields and features from our output. So I've got that filter, so it's excluding this. I'll use everything default. I'll use the ensemble techniques and everything there. In fact, just for, I'm going to create a confidence model. A confidence model will just give us an extra field which says what's the range of the values. So it'll say that the value could be, there's a confidence that the value will fit in. There'll be a minimum range and a maximum range. We might not use that, but I'll just create it just to show you. Okay. Okay, let's see what's next. One key thing that you want to see here is models right now. These models are just like all the models you create here are not published. Okay, publish, before you operationalize, you need to publish the model. So you'll see publish is grayed out. But for each of the other ones, I could publish these. I could also export these. These will be exported as an XML file, and you can see what it looks like. So this is what our model actually looks in an exportable format. And you can use these. I mean, I think PMML is supported quite a bit. So these could be imported into other things. So it has defined the layers. You can see it's a regression table, the regression model. Was this only for the regression model? Because maybe that would explain why transformation directory. Okay. Yeah, I think this is just for okay, no, this is using different things. I think this was only regression. But you can see how it like applies there. So linear regression model is there. And it gives you these fields, and these could be imported into, I'm just going to close that. Let's go back. My thing must have been created. Now, if you look here, You're not going to see anything about the confidence index. A little bit our predicted results have come down, but it's fine. Sometimes you have to make a compromise. We're going to use this to operationalize because it's still pretty good. It's not as great as the other one. Our RMSE is around 6, but for the purpose of predictions now, we don't have to get perfect predictions. So I'm going to use this model. Now, how do you operationalize the model? This has to be done in Analytics Manager. So you come to Analytics Manager. Okay, the first thing you need to do is select an analysis provider. And I'm going to do this. You don't all need to do this. I'll just create one. We can all use the same. So I go to the provider name. I'll just call it something like, concrete analysis provider. I have to select a connector, and I'll just use the default analysis. Again, everything is copy and paste. So I just have to do that. The rest of the fields can just be left empty. So this is just our provider. So this is the engine for running our analysis once a model is. So under analysis models, you'll see nothing because we've not published our model yet. Now I would go back to our model. I'm going to use the latest one that I did. So I'll just go here. I select the model that I have and I go to publish. And it says, are you sure you want to publish this model? Now this will be available elsewhere. It'll give me a pop-up, which will give me a few different fields. It says this is the provider that we have. Data shapes are actually, ThingWorx record shapes. So it gives us like the input data. It gives us 2 input data shapes and a result data shape. The input data shape has all the fields that we selected. Remember, we left out some. So when we send predictions, these are how we send the input parameters. We'll send age, cement course, and we'll fill it in this value. This is the format for that. Result data shape is how we get the results back. That only contains compressive strength, which is our value. And there is confidence min and max, which is because we chose confidence min and max, there's a range there. And you can ignore the other fields. It also tells us important fields. We'll see that later. Important fields are actually, it tells us which fields for each particular prediction, which fields were most influential. So it gives us a scoring. So that's also useful. And when I show you the Bean Pro Express data, you'll understand how it works on there. Okay, so coming back to, we don't have to be on this. Once you've published your data, publish your model. By the way, if you want to test out your model, again on that thing, you can come to test also. So you can input particular values for cement water, like you can say, 12, 13. I don't know if these are even valid. I'm just going to give like, and it'll just make some prediction. And you just say you add row. I don't need to put any of the other stuff. And then I just, if I just say submit job, so it'll give me a value. Selected field is not info table. What? No. Okay, it's not actually given the thing. So as it maybe it needs, yeah, okay. So again, it's all asynchronous. So it gives me, says that if I enter these values, I get a value of 45. These are all accessible, by the way. What I need to do is from here, I need to make sure I enable this model. Okay. Now, remember before my analysis models was empty. Now that I've published it, it should show up in analysis models under Analytics Manager. So I've got one. I can see other people have also been creating there, and you can see the different things. Mine is enabled. The enabled is an important one to look at. Now, what we need to do, and you can just follow along with this since we are running a little bit short on time. You can definitely play around with it later. And I've also, in the data set that I've shared with you, I've also created some things. There is a, if you look at, there are like 3 XML, there are a few XML entities. You don't need this, like, again, it will overwrite. So do not, put these out. So ThingWorx concrete timer, Things concrete data thing, and concrete mashup. These are the 3 XML things that I've shared there. You can definitely include, but I've already created them, so you don't need to do that. Okay, so now that we have all of these, we need to go over to ThingWorx Foundation. Let's leave analytics behind and let's go to our things. Okay, so I have created something called, oh, sorry, I've spelled it wrong. I've created something called concrete data thing. Okay. Now, concrete data thing, if you look at the properties and alerts, I've already populated these. I've added all the fields that we need. So we need our 5 features are age, cement, coarse aggregate, super plasticizer, and water. Plus, in addition to that, I've also added two properties which are like set by default, which I expected. We saw them in the, if you look at this, this is corresponding to the data shape that's here. So causal technique and goal field are two additional, which have to be passed. So this, by the way, is a static thing. It's not connected to the edge, so no values are coming in. I'm going to simulate these values now, but right now there's nothing coming in. This is just in this. So the goal field I just added, the goal field, I don't need to set a value for it. It's just blank. It's a string field. And causal technique is a string field, which just has a default value, full range. I've also added for my predictions to come in, result underscore compressive strength, the confidence values, and underscore MO is a normalized one, which we don't need. We can actually get rid of this. But the main thing is this result underscore compressive strength. This is where our prediction will be stored. Okay, so I'm just going to go back to this. What we need to do is we need to, first of all, let's start. We have to do a simulator here with this. How I'm going to run the simulators, I'm going to use a thing that's called, that is derived from a timer thing. Let me see if I've got that. Let me just make sure I have everything here. So I had already created something called concrete underscore timer, but it doesn't seem to be here. Oh, no, sorry, it'll be under timers. Yeah, so I had created a timer. Now a timer thing is just another thing. It has properties and alerts. It's exactly the same. Only difference is its base thing template is timer. So it is extending that. We've used it in the past. And I've given it an update rate in milliseconds, which is 10 seconds. So every 10 seconds, my timer, this concrete thing, will throw up a global event. Okay. And right now my timer is disabled. And what I've done in my concrete data thing, if you look at that, I've created a subscription. Okay, so this is key to remember. You can also use the same timer object with different things. If you create a thing, if you call it concrete data underscore thing underscore 2, it will do that. But please don't import those data bits right now because it will overwrite this. So I've created a simple function there called simulate data. This just fills it with random values. This is all JavaScript, by the way. So I looked at the range and I said, just fill in the cement value with something within that range, the water value with something in the range, age and superclasses. So this will just put in different things. And I've set it up so that it is a timer. I'll just set that out like here. So if you look at the this one, and you can do this, normally like I've set up the event so that it works on another entity, which is concrete timer. So this is how I've set up the bridge. And every time timer, I've set up an event on the timer.timer event. So every time the timer completes 10 seconds and it sends out an event, it is caught by this thing. And this is a very powerful thing which we've used in the past, where events can be sent out and subscriptions can be done to handle even between things. So you could use this timer now that I've disabled the timer and I've disabled this thing. So I want to make sure that it is enabled. Okay, this is enabled. So my concrete data thing is ready. Now, if I go back to properties and alerts, now I should go back to concrete timer. Again, I need to just use the built-in, like if you look at the properties, there are default properties enabled. It's false right now because my timer is not running. So it is not sending out a signal every 10 seconds. I'm going to enable the timer now. It's just a simple function and it doesn't return anything. When I do this and I come back to properties, you can see the value is now on. So now my timer is on. Now, every time my timer runs, my values, my subscription will be called, the JavaScript I did, and it will be building up. So you can see values are starting to fill in the fields I was populating. So cement has a value, course aggregate has a value. And if I keep refreshing, so it changes every 10 seconds. So this is a simulation of what happens on the edge. The edge will send data every 10 seconds. It will be getting modified. But we haven't still set up. What we want to do is in real time, we want to capture these fields. We want to send it to a prediction model and then generate a compressive strength for each value. And we'll do that or probably presumably every 10 seconds also. How do we do that? So let's come back to analytics. Okay. For the time being, since it's like doing a lot, I'm just going to disable my timer and I will come back to that later so that it doesn't fill up values. So let me just do that. Just go back, services, and go to disable. So this will stop the population. If you go back to concrete data thing in 10 seconds, it won't update. It'll just stay at this value. Okay. but we must remember to enable it again. So now let's come back to analytics. We've created an analytics model. Now we want to operationalize the model by creating an analysis event. An analysis event occurs every time something happens to another thing. In our case, it's concrete data thing. So let's go to concrete data thing and create a new event. Yeah. So we will call it, the source type is a thing, our thing that we have, which is called concrete data thing. The event we want is that anytime the data changes on concrete data thing, we don't want it to run unless some data changes. And in fact, although we have 5 fields, I'm only going to tie it to one field changing. So maybe I'll tie it to cement, the cement value changing. So every time the cement value changes, this analysis event will be called up. It'll perform the prediction and send the value back once we do a few different things. And then you just have to select concrete analysis. I'm going to just select the published value. It gives me everything in there, and the rest can stay as it is. Once we do this, this has created the analysis event. The next thing we want to do before we enable the event is to map data. Now we come back to map data. We have to first go to the inputs mapping. Now we have to map the values here. In fact, I don't do source type, should be thing and concrete data thing. We have to map according to the input data shape that we saw. So we have, for example, age is mapped to age in the input data shape. So we have to do this one by one. Cement is mapped to cement number, course aggregate to course aggregate. These values are not, these are output values, so we don't touch those. These are all the properties that have come from the thing. Super plasticizer is mapped there. You can see it's updating there also, so you can see the values are changing. Water and water is mapped. And in addition, we also have to map causal technique and our goal field. Remember, those are like default fields that we had added on there. So this maps all the inputs. Now we have to map the outputs, what returned by the job. Again, we do the same thing. You can take event source, or we can just take thing, if it doesn't give that. So we've got that. What we want to do is we just, in fact, we can get the value of compressive strength and just map that. So it will fill in the value, whatever comes back from the prediction job will be mapped to the property result underscore compressive strength. So this way the thing, the event will directly populate. So our prediction will be directly populated on there. I can also map these, the confidence map max. We don't really have to bother with that, but it's a range. We can just see that. I'm not going to bother with compressive strength underscore MO because that value is pretty useless. It's just a scaled down version of this. Once we've done this, we have everything ready for mapping. We should go and enable our event. Okay. Now, right now, it won't do anything because our values are static. They're not changing, so nothing is changing. What I need to do is I need to go to my, I need to go back. I've enabled the event. I need to also re-enable my timer so that it starts the value. Okay. So now my values should start refreshing, and you can see my compressive strength is getting filled in. So you can see now this is a full-fledged operationalized prediction model. You can see that like when these values are there, it's giving a compressive strength of 76 and it's giving a minimum value, based on our confidence level. So it's saying like, the value will be between 70 and 81. It's not updating compressive strength underscore MO because that is obviously not as useful. Okay, so now that we've done all this, I'm going to actually like show you how you can actually go back. Let's just go back to analysis quickly. You can see the list of like, there is a log under analysis jobs of all the completed jobs, all the predictions, individual predictions made. So everything gets logged. So this is what it says. The input was this. This was the input for your, where we passed the values, all the values that were given, and the output also was given. The output would also give like we didn't select important fields, so it didn't show anything, but there's no error message. So all the values that were done, and these are automatically being passed on. So you can see the values from here, and important fields is not populated, so we can't really see that anyhow. Okay, so this is like a way the jobs can also be seen. So you have everything is viable here. Now, of course, we talked about mashups. I've actually created a dummy mashup already. And you can see that I haven't bound the data. Mashup. So like I said, a mashup is a visualization tool. It's a web application that can run. So I just created a sample. Like if you look at the mashup right now, there's no data bound to it. So it'll just show you the headings. So the great thing about ThingWorx and mashups is like most of you, as you are developer users, you are logging in and seeing Composer. Using the same interface, I can log in normal users and I can give them a mashup that they will be redirected to. So your users can see the mashup as the first thing and it would just come from the same location. Right now, all the feeds are blank because I've set an auto refresh, which is refreshing every 10 seconds or 5 seconds, that will refresh the values, but I've not bound any data to it. Again, binding data is really easy. We just have to get it from the thing. I just go to bind thing. My entity here is what was it? It was concrete data underscore thing, right? And the service that I want to get is an inbuilt one called get properties. So I put that, I wanted to execute on load. So the first time the page loads, I wanted to retrieve all the properties for concrete data thing. And then I'm going to bind each of these one by one. So binding is just drag and drop. So data, cement, that gets, oh, did I not? It did not bind. It just gives me, I can bind it either to the data or the label. So if I wanted to change the label, where is water? I've got a few. These are all also, by the way, responsive segments. I made the top one static, so just so that we can see it properly. So I just bind all these one by one. You can see once it's bound, you can see the black mark on there. The next workshop we do will probably be focusing more on mashups. So if you are interested in learning more about this part of it, which I find is the most fascinating part of, oh, I bound it to the wrong one, so I don't want to do that. And I bind super plasticizer. So this will show my values, then compressive strength and confidence, max and min also, I will do that. And you can see all your connections lower down. Okay, so I've just got this. I'm going to save it, and then I'm just going to refresh my max. So you can see the values are coming in from the thing, and they are populating automatically. Oh, I didn't bind the. I have to actually bind get properties also to my refresh widget. So I take the refresh object and I just drag and drop it to get properties, and then save. Now it'll automatically refresh. So every time 10 seconds happens, based on our timing, I won't have to hit refresh or hit refresh here. It'll just automatically, you'll see a check bar. So I'll just wait 10 seconds and it'll give you the next result. So there you can see the values have refreshed after 10 seconds. So you can set up all these complex mashups and you can show people all the data. So this is pretty much everything we wanted to do with this particular real world data thing. I don't think we have much time. I want to wrap this up by 7 latest. So we will quickly look at the Bean Espresso counter, but we won't do a full workshop on that. And I will quickly mention our homework at the end, but let's just stick with this for the time being. So we've done like everything with the concrete one. The Bean mashup again is a simple data set. In fact, I will show you, we've got, so one of the great things about ThingWorx also is like, everything can be packaged. So I've actually got a portable version of ThingWorx that works on localhost. So I can actually just run it. It just runs so it's just running a version of this and opens up a local ThingWorx. So this is all running on my local machine, and it just takes some time to refresh. Oh, I need to. Because I think my password is stored on this. Well, no worries. Let me open up a incognito window and try it again. I think that's because of cookies. It's already saved. So I'm just going to quickly do this. So we'll just look at the demo for that. If you want to play around with the Bean process data, it's already there also on, you can see there, if you go back to the analytics, I have put that up. That is a large data set and it gives much nicer results. In fact, if you see there, I'll just open up the data set so you can see what it looks like first. So this is a great data set and it comes with the, with ThingWorx bundled also. Just look at the CSV. So yeah, so it's a very large data set, and there are three failure goals here. You can see here, grinder error occurrence. So it's 0 is whether there is a grinder error or there's no grinder error. The three components that could fail are the grinder, the pump error, the pump, and the heating element. So in each machine, so it does have like 3% goals, and you can use, and it has a lot of different fields. So there's a lot of data here. Plus, it's got like multiple records, so you can get a lot of good, and it does give a pretty good model as well. So if you see the espresso machine, let's go straight into the models while the other thing is loading up. So if you look at, there's actually a model I've already created. This model is pretty decent. Again, we're back to ROCs because it's it is again like a Boolean variable on there. You can see the model configuration we did here. We just used the default. We didn't really do anything, and it's a good one. You can see a good ROC here. The validation metrics versus the training metrics are pretty matched. Your ROC, as always, it's best if it like an ideal ROC would be along this corner where 100% of the area is under. So this is a pretty good one, where you set up certain values, and we've got a fairly good. So this is a good model that has been generated. And okay, one thing I did want to show you, which I didn't show you with the previous one, and you can create signals and profiles, but we don't need to worry about that from here. In fact, I'll just create signals and profiles to let it create on its own. So it'll create signals automatically from here. So you can either create signals and profiles from there. We want to look at the predictive scoring. Now, predictive scoring, the great thing about this data set, I'll just come back to the model. When I created it, I ran a filter on, I created a row filter on it. So a row filter, I've created a row filter called training data. Okay, now if I go back to my data, and if you look at this, so my espresso machine data, right? You can create filters from here. So filters can exclude particular rows. Now, if you look at the data again, should get that open. So there is a particular field called record purpose. This is just a flag. It has values only as training and scoring. So two values possible. So training and scoring. Now I created a filter that had only training data. So all the fields, which are like about 98% of the records, are for training. So I scored it as 90. This is not to be confused with validation, by the way. This is still the training data. It'll still take a subset of that for validation. But this is all the data that's used in the model. And I've kept like 1,000 records separate for scoring, so I can manually score them. Okay. Now, coming back to the model. Okay. So, by the way, we can see the signals should be created by now. Let's see if there's something first before I show you the scoring. Okay, it shows, again, the most is the average daily cycles, which is how often it is used. That value is pretty influential. It's a high correlation with failure. So, which makes sense also. If you use your machine more, it is more likely to fail. And you can actually correlate that. Now, the profiles will give us something more interesting because it will show how often it'll give us nice combinations that cause failure. So it says average cycles, 12.96, when average cycles are between 350 and 483, high usage, 12.96% of the time it is causing a failure. When you combine it with a particular grinder type, satellite, and a heating element, okay, we should actually have excluded heating element error occurrence because that's another one. So if a heating element hasn't been happening, it is still likely to cause this. And latitude, okay, we should have actually excluded latitude. So signals, latitude, these are again noise in the data set, which we should have removed, but we get an idea for that. But you can also look at this. Okay, this is an interesting one. This profile is probably the most useful. So if you look at it, it says that when the priority codes, which are like service calls, were like 2.4 to 4, there was a high institute of failure. And when you combine that with the daily cycles, that was also between 324 and 350, that was also causing failure a lot. The grinder type also influenced, as well as the average pressure. So this gives us a nice, it gives us a nice scale down value of seeing that. Okay, so that is this. Let's just look at predictive scoring. I had actually already done this, but I'm going to create a new scoring job. So I'm just going to call it scoring job dash grinder 2. I'm going to use, like I said, the scoring data filter, which is only 1,000 records. So it's going to take from the same data set, it'll take 10%, just 1,000 records out. And here I can decide how many number of important fields. Remember, we were talking about important fields. This will say which are the important fields that influence the goal. So for each goal that is predicted, it'll take out the field. So we'll say 3 fields, right? And we can select which, identifying fields. Let's make this will be showing us. This will show which fields. We don't want to see everything there. Let's see. Where is that? We want to see cycles info. Cycles, like we already know, cycles are, say the daily cycles. We want that in our. We can also alternatively just put everything in. These are different metrics for each. So these will say these are the values that will be put in there. In fact, let's just leave it at that. Average maintenance type. Let's also put that. When we do this and we just hit submit, I think I hit click submit twice, so it's running it twice. Okay, let me quickly check if it did load on here. This is from the ThingWorx demo set. So this has been shared by the folks over at PTC. They've created a mashup on the same, which we, on the same, like to give us a visualization of that. We just come back to that. This model would obviously take a lot longer. So if you are trying to create a model and you can try creating a model on this, it'll take a lot longer than our other models, which had just 1,000 1,000 or so records. Okay, so this, remember, is a separate data set. It's not coming from our models. This actually is is a very impressive demo that they've done with the BeanPro data. So you can see by drill down, you can create a mashup where you can see every single machine that's anywhere. And these are predictions that are coming. So it says that based on what values are there, the current values, it has a low heating element risk, a moderate pump risk, and has a grinder risk. These values come from ThingWorx Analytics. It says which are the contributing risk factors. These are the important fields we just specified. So when priority codes are level 0, 2 or something, then that is what's causing the low risk. And a moderate risk is because of these contributing risk factors. Similarly, it also has like a way to show about, and remember, this is getting data from there. Like it shows all the signals. So like we create signals in the analytics extension, it shows like the different types. So it says pressure is the most influential signal. You can see the values, the average goal when it's like it's directly correlated. Whereas some of the others like cleanings are not so influential. That's why the values are so low here. It shows you all the profiles. So if you look at like the profiles, of course, this is the left side is unrelated. So the profiles, it says that when average cycles are between 351 and 377 and other alert codes are 0 to 1, there's a 9.3% failure rate, which is quite high. So you can predict when failure happens based on these rates, even before it happens. And it actually also gives you some info about scoring the prediction models. They tried 3 different models. So like the grinder one used decision tree linear regression, whereas the others use backprop, which I guess is a neural network. And it gave you the RMSE. The RMSE is much, much better than what it was before. Of course, this is RMSE, remember, is on 0 to 1. So, in the other case, it was on compressive strength, which is a continuous value, and it's got a lot more records. So it also does the machine scoring, like and this keeps refreshing. It scores on generated values like we are doing. So all these functions, they have encapsulated on there. Okay, so our scoring report is done, and it gives us a CSV file with all the fields that we require. So we asked for, you can see this is the output there. The grinder error occurrence for each value that we set as the input. So we gave it 3 features to use. We said use cycles where, and it used its own variant, like it selected its own. We don't control which features it used. it just uses the field, the values out of the ones. It's a, we said use only 3 features maximum. We could say use 5. That's the maximum number that we had, in our model. And then it predicts the value. It gives the grinder. It says, what's the error occurrence. So this is important data that you get about that, So, and we asked to show these additional fields, like what are the values of these when this happened. So this is just a way of scoring data. So it scored it for 1,000 records, and you get this automatically. So you can batch process on this. I'm not going to save this. So this pretty much covers Bean Pro also. I did rush through this a bit, but this is just to give you an idea. Now, the last thing I said, and we will wrap up in this, so it's just the last few minutes, is of course where we want to work with some custom data. Okay, now custom data, of course, everyone's favorite source for custom data is Kaggle. And I'm going to go into Kaggle. We found a particularly good data set, and I've also already shared this, so this is already part of this thing there. This is a data set on water potability. So it is again a Boolean one. It says either the water is potable or not based on different factors. Now, this is a real world data set, so you do have to be careful with it. When you are creating models, you can see like, okay, Kaggle also defines a lot of the tasks. People have tried their code, but they've not obviously tried with ThingWorx. Now we are going to try it with ThingWorx. Let's close everything and let's go back. So this data set is already there. You will actually see 2. There is water potability and water potability cleaned. Water potability has about 3,000 records. That's the original data set. I would not use that because if you look at it, it's got a lot of blank values also. So we did a little bit of cleanup at the lab, and we did so you should use water potability cleaned if you are importing. The data is already original. There are about 2,000 records. It's not so much. So we created a record here, and we've already got the data. So what we want to do is, in fact, I'll just quickly run a model on this, just using the default. I'm going to use water potability data. The goal that we have is potability. So is the water drinkable? I'll just call it water potability model. I'm not going to exclude any fields, and I'll just use the default. Now, we're used to using data sets that gave pretty good results. This one actually was a bit challenging because it's a real world data set. We don't know what to expect. The best we could do, we did actually get a few, we did run a model earlier and we tried a few different things. The best we could do is about a 72% ROC. But here is where it's interesting. Remember I said this could be like, this could be a very good example of overfitted data. So if you see the training ROC, it's pretty good. It's close to the thing, which is a good sign, but the validation ROC is not so great. It's coming closer to the middle of the line. So what this means is that the likely is the data is overfitted, but still 72% is good. 72 or 06 is good. So overfitting means that when the data, it takes the training data and it makes a model that is too close to all the points. So it's not generalized enough so that if we give it new values that are outside of the range it already knows, that it will perform well or it will scale well. So so it is actually, this is the best model we got out of that. And when we did that, we have the model configuration. We actually experimented a lot. We ran like multiple gradient boosts. We didn't actually need that. I think it just got duplicated. We ran multiple random forests. You could probably just do one gradient boost and one random forest and just run the ensemble. You could change the number of trees each uses. Gradient boost and random forest is probably the best method for this. So you could try this out. So I would recommend creating that. Just coming back to, again, this is what the default one was created. Gradient boost actually did the best, and this is not so great. Like you can, the validation is somehow we got lucky. I'm not sure how exactly, but it depends. And again, if you retrain, this is actually pretty good. But it's not always predictable because it depends on how the training data is selected, how the 20% is there. If you tried retraining it and we did that, we're just going to try creating it again. But just let's look at this. This is actually pretty good, the ROC, and we could use this model. But again, it might still be overfitted and we don't know it. It's the training metrics are probably quite good. And so what we want to do is like try all the different methods, try different things, using a bunch of the models. So this is actually good. I mean, this was not expected, to be honest, because when we tried it previously using different methods, it was giving all sorts of values. So let's see if it comes again. There's a pretty good ROC. Any ROC that's above 0.9 is a good value. So what we want you to do is take this data set, create your own models. Of course, don't forget to prefix them and do different things. And I will leave this data, all this data is going to be up for at least a week. Okay, so you can have a look at all of this and see what you can do. Try to get the best score. So, and report back to us the person who gets the best ROC. Let us know how you get along with it, and see how it is performs. You can try creating operationalized models. You know how to do it now. It's very simple to do. Again, the ROC is pretty good, so the value is actually quite good. So this is a good reading. It's selecting nicely, it's trained it nicely, and the validation is pretty good. So the homework is just play around with that. See how it responds to different model configurations. If you just did a linear regression on this, how would it process? We could in fact try that. A linear regret. Let me just do portability _ LR. Portability data. Or maybe I didn't select the right field. Did I set portability as that? Let's get rid of all the other learners. Let's only leave a linear regression, see how it works. Okay. Oh, by the way, I forgot to show you that. When you do select the portability data and you look at the advanced, you can see and you select portability, you'll get different values in your advanced model configuration. So now you have a sampling strategy, and I would suggest look up on ThingWorx developer. You can find out what all of these mean. You can upsample, you can downsample, you can put custom matrix weight for your ROC. So you can say that I want my true positives to be twice as influential. So I put that. We will at some point come back and do time series model in a future session, but that requires a separate. So this is just about this. Okay, so the linear regression completed really fast, but as you can tell, the ROC is awful. It's pretty much like an average ROC, just a straight line. So compared to when you have the training data, again, training data will not be great because it's trying to fit to a linear one. So you can see, so this is not a great model, and your predictions from this will have a lot of problems. So linear regression doesn't work on that. Well, that's about it. I'm just going to come back to my screen. I hope everyone has followed along. We wanted to give you guys an intro into this. It is, of course, and this is not just going to be one session, of course. We wanted to start up with a new thing with the access. We want to build up a community, and we want people to be discussing with each other. We want you to be working on the sessions, even between the workshops, and feel free to write to us at any point if you want to gain that. We'll be happy to help out with anything to do with that. It is I don't want to stress that too much, but it is quite a good experience that we can work with the ThingWorx tool, thanks to Etisalat, because normally I can tell you, ThingWorx is an enterprise software. Big organizations use it. Even training on ThingWorx is very expensive. ThingWorx has training classes. It's a high premium thing. But we wanted to build up a grassroots community on this. So people like yourselves, whether you're from college backgrounds or from universities or doing different things, we want you to work with this system. So we have given free access for this, and this will stay. We will clean up the data from time to time. We have to manage this. It is quite robust and working. And next time when we work on that, maybe we'll shift the focus from analytics to mashups, and you can try all that. But please do use the system. We will be monitoring, of course, so that it doesn't get overloaded. But please do keep using the system. We will be doing a few reboots on the system once in a while, and hopefully that will give you that. Okay, so please do send us your comments also. And I'm going to stop sharing now. That finishes up our session. Please do share your comments. Tell us how your experience was and how we can improve. Also, of course, that's always there. How we can do this. We are going to upload this. It's all going, by the way, it was already live streamed to our website also. So you can go back and see the recording in case there's something that you didn't follow, you'll find it over there. So please have a look at that and let us know in detail, like, how you get on with the sessions, how you get on with the work. So I gave you a little bit of homework, but you can practice on the other things we've already worked with also, and keep going with that. Bring your own data sets in, that is open also. As long as it's not too large, let's be considerate. We might delete something if it's too large, but bring your own data sets in, practice on this, see how you can improve, as opposed to, say, working with Python. And the goal, I believe, from ThingWorx, and this is going to be a big IoT revolution from PTC, is they're going to combine all their separate technologies, not just Foundation, not just ThingWorx Analytics, but also things like ThingWorx, AR. So you could build an augmented reality experience, which is getting values from machine learning. So you could have, you could be looking at an engine, with your VR goggles, and you could be looking at it, and you could be getting the predictions right into your AR values. So ThingWorx is trying to combine all that. You could be building that from Creo, which is also owned by PTC. And so there is going to be like a consolidation, and it's all going to be cloud-based, just like Amazon and other providers have all cloud-based. Right now, ThingWorx is is installed, but they are ramping up the cloud solution. And of course, Etisalat is also works a lot with VMs and with the Etisalat programs. So please do get in touch with us. Send us your comments. Let us know how these things are, and we'd be happy to share any information that we get also with you. So have a great session, and the next session will probably be next. I think we'd probably do it next month. We are aiming to do these at least once every month, but we will organize again, and we'll again do we will be doing on Zoom for now, but we will also hopefully start doing live workshops so people can get together also soon. Thank you, everyone. Have a great time, and good night.